And this is section 11.3, so we're kind of going backwards here. And this is all about the tangent line, okay? The tangent line, okay? And so to make a tangent line, if I have some curve, let's not make it, so I have some lines here, and I make some curve like a parabola, try to make a parabola or something, okay? And the tangent line is a line that goes from one point on a curve to another point. Well, the tangent line is actually the line that exactly touches the curve in one point. Remember that from geometry? A tangent line is something that touches a circle at one point, right? And only touches it once, okay? And the tangent line is very important because it can tell you the slope of a curve at any point. Why would you want to know the slope of a curve at any point?
So you can find out what the slope is.
So you can find out, but also if this is like the height of an object, and this is like time, what would your distance divided by the time give you?
Slope. Rate of change.
It would give you the rate of change. It would give you the distance at any point. If this is a curve of velocity versus time, what's the rate of change of velocity over time? What's the velocity divided by time? What's the rate of change of velocity?
Change in speed.
The rate of change in another name for change in speed is
Acceleration.
acceleration, right?
Yeah,
So,
acceleration.
so rates of change are very, very, very important when it comes to calculus and in real life problems, solving real life problems, and in and like business even. If you want to know like when does the rate of change stop increasing and start decreasing, if you're opening a business, see what's happening in your business. Anyway, so that's the tangent line. If you draw a line that is not exactly tangent to the curve, okay, that goes through 2 points, kind of like, it's not very good. I'm just going to bring this over to here and make it more, that didn't work either. If I were, let's get rid of this. If I were to draw a line from here to here, going through this point and this point, that line has a name too, and that line is called the secant line, right? Secant line. And you can find the slope of the secant line. If this is the point x, and I move over a distance from here to here, look at this one. A distance from here to here of h units, then this point so this point right here would be x comma f of x. You understand that? What that means? X comma f of x? X, y. F of x is what I give. This point over here, if I move over h, it's going to have the coordinates x plus h comma f of x plus h. You guys understand that? Because if I move over h, the x coordinate at this point is x plus h, and the y coordinate is going to be f of x plus h, which is what I get when I plug in x plus h into whatever my function is. Okay? So the slope of the secant line, that means slope of the secant line, it's just delta y over delta x, change in y over change in x, which is going to be f of x plus h. This is how we find the slope of something, minus f of x over x plus h minus x. What's x plus h minus x? What's x plus h? It's just plain old h. See that? And that's called the slope of the secant line. And so that will give you an approximation of the rate of change, but you can see that's, depending on how big I make h, it's not a very good approximation. But as h gets smaller and smaller and smaller, I get a smaller and smaller triangle. You see that? And if I make this triangle infinitely small, right here, the slope will be exactly the same as the slope of that line. And that line is called the tangent line. And the slope of the tangent line, and instead of using delta y and delta x, they use dy dx, which implies that that change is infinitely small, dy dx. And that's equal to the limit as h goes to 0 of the same thing, of f of x plus h minus f of x over h. And you already saw some problems like this in your homework, right? Yes? No? Okay. So the slope of the tangent line is equal to the limit of the slope of the secant line as h goes to 0. As you move this point closer and closer and closer to here, this line, this secant line gets closer and closer and closer to the exact slope of the curve at that point. Yeah? No? Questions? All right. So how do you use that? Okay. So how do you use that? I don't like that paper. I like this paper better. Could see better on it. Find the slope of the graph. Find the slope. Slope of the graph of y equals x squared plus 1. X squared plus 1. Can you see that? When x equals 1. All right. So in other words, I'm going to make a little curve. Y equals x squared plus 1. What does that look like? Parabola that goes to 1. At x equals 1, so this is a point 1 comma something. 1 comma what? 1 comma 2. So a lot of times they won't give you that y coordinate, but you can find it by plugging in. What you're trying to do is find out the slope of that line right there. Okay? So we're going to do the limit process to do that. So I'm going to take the limit. We already did this in your homework if you did it. The limit as h goes to 0 of f of 1 plus h, in this case, minus f of 1 over h. You guys understand what I just did?
Yes.
Okay? So f of 1 plus h minus f, I'm just plugging into that formula, but in this case, x equals 1. So you want to find the slope of the graph. So now you got to take this, and this is where people get confused. I take 1 plus h, and I plug it into this equation. So I'm going to go the limit as h goes to 0 of 1 plus h squared. 1 plus h squared. What I'm doing, I'm taking 1 plus h, and I'm plugging it into this equation. 1 plus h squared plus 1 minus f of 1. What's f of 1? 2 divided by h. Who doesn't understand what I just did right there? Okay? I took 1 plus h, I plug it in there. This plus 1 comes from here, right? Because the equation is, I have to plug in this in, but you only plug in for x, but then there's also plus 1. And f of 1 is what I get when I plug in 1 in here, which is 2. Okay? Now I simplify and try to find the limit. The limit as h goes to 0. I FOIL this, remembering that there's a middle term, 1 squared plus 2h plus h squared plus 1 minus 2 makes what? Minus 1 over h. And then what goes in? Yeah, there is a limit. This goes away, right? And then I have the limit as h goes to 0 of 2h plus h squared over h. I would get 0 over 0, but what can I do?
1.999.
I can cancel out an h here, here, and here. Okay? And I get equals the limit as h goes to 0 of 2 plus h, and then I can take 0 and plug it in there, and I get equals
I was 0.001.
equals 2. Okay? And so that is the slope of this line. Slope equals 2. Okay? If they ask you to find the equation of the tangent line, which they will, find the equation of the tangent line. I'm writing pretty neat up here today. Equation of the tangent line. Okay? All you have to do is you have to plug into this formula. Y minus y1 equals m times x minus x1. Do you remember this? What's that called? That's called point slope, but in this case, m is that's the slope of the tangent line, right? And so if I plugged in this number 1, 2 and this slope, I get y minus 2 equals 2 times x minus 1, right? And this is fine to leave it like this in point slope form. But if I did want to get a better picture of what that looks like, I could put it into slope intercept form, which is just plain old y equals 2x, right? Because I distribute this, I get minus 2, add, you get y equals 2x. And if you can see in my picture up here, I drew that pretty accurately, right? That looks like y equals 2x. So this line exactly touches this curve at one point, and the slope of that curve is 2. Questions? Did I mess up? Y mx, whoops, minus x1, sorry, minus x1. That's point slope form. And then, so when I plug in the point 1, negative 1, 2, and 2 for the slope, that's what I get. Okay? The slope of the tangent line has many names. Anyone else know what else it's called? Derivative. That's right. Okay.
Oh my.
It's called the derivative. Okay. So another name for the slope of the tangent line. Slope of the tangent line is equal to the derivative. Okay? They say derivative. And it has lots of other names. Okay? Like I said, sometimes they call it dy dx. Sometimes they call it f prime of x. Sometimes they call it just y prime. And sometimes they call it d dx of f of x. And they probably call it a few other things. Probably when you get to really hard derivatives, they call it a lot of other things, but like bad things, you know. But those are different ways. So if you see this, 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 it all means the same thing, the slope of the tangent line at a point. All right? Questions so far? Okay then. Now, we're going to do 2 more problems. 2 more problems? Yeah, 2 more problems. Okay, so sometimes they want you to find the equation of the tangent line. Find the equation of the derivative, not the tangent line. They're 2 different things. The equation of the derivative of f of x equals x squared plus x minus 2. X squared plus x minus 2. So this is a really good thing to be able to do, because what this lets you do, instead of just finding the slope at a specific point, you can find, using, if you have the equation or the derivative, you can find the slope at any point. Right? So in this case, I'm going to use my same formula. I'm going to take the limit as h goes to 0, of f of, in this case, f of x plus h. So I don't have a value for x. I'm just putting it in general terms. Minus f of x, that whole thing over h. When I plug that into this function, this is where people don't get confused. I plug in x plus h in here and in here. Okay? And I get x plus h squared plus what? X plus h, I plug it in here as well. X plus h minus 2 minus, and I'm going to put in parentheses, f of x, which is just this right here. X squared plus x minus 2. That whole thing over h. And you say this looks horrible. Okay? It's not that bad because things disappear. Watch, it's kind of fun. Let's change colors. You get the limit as h goes to 0 of, when I FOIL this, I get x squared plus 2xh plus h squared plus x plus h minus 2 minus, I'm going to leave this in parentheses, x squared plus x minus 2. That whole thing, whoa, over h. And then what I do is I can cross out some things. What happens to this x squared and this minus x squared?
They cancel.
That cancels with this. See that? What happens to this x and that x?
They cancel.
This is a minus x. This is a plus x. That goes away. I have an h squared, 2xh. What happens to this minus 2 and this plus 2? See, it's minus, 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 minus. This goes away with this. And what I'm left with so far is the limit as h goes to 0 of 2xh plus h squared plus h divided by h. Now what?
Divide the whole thing by
I can divide everything by
h.
h. That turns into an h. This turns into a 1. So what I'm left with is the limit as h goes to 0 of 2x plus h plus 1. Then what? Now I can take my 0 and plug it in for h. And what I get is this is equal to 2x plus 1. Big deal. What does that tell you? What this tells you is the slope of this curve at any point. Okay? So if I go way back up here, what was my curve? What was my curve? Where's the
X
beginning?
squared plus x minus 2.
It was h. It was, oh, is it on the, oh, it was on this page?
Yeah.
Where was it? Oh, right there. X squared plus x minus 2. So if I have this, I did in the last class, this curve, it has intercepts at 0 and then again in -2. If I FOILed it, I would figure out that this looks like, whoops, goes through there like that. And then say I want to know what is the slope, what's f prime, so sometimes I'll say like this, what's the slope at 2? How would I do that? Plug in 2 into here, what do I get out? 5. So if I go over to 2, 1, 2, my slope of my tangent line is very steep. It's going to be the slope equals 5. How about if I went over here to like -2? What's my slope? If I plugged in -2, I get -4 plus 1, which is -3, which would make sense because this has a negative slope there. See? Okay, so this equation will tell you the rate of change at any single point in that parabola. Is this too much math for the last day of teaching?
No, I'm just wondering who figured this stuff out.
Yes.
Who figured this out?
Can you do one more example?
Isaac Newton and Leibniz. Okay? And Leibniz, another German mathematician, but they figured out to discover the rates at which planets are moving and all that kind of stuff, and it helped them calculate distances to the sun and all that.
I did it, send you a homework.
What?
Can you do one more example?
Yes. I'm going to do one more example. Very good. I was going to thank you, Henry, for asking me another example. All right. So one more example. Find. So this one's a little bit different in that it's not a quadratic equation. Find the equation of the derivative of the derivative of y, or f of x, equals 1 over x. Okay? You ready? So this one's a little bit different, but you do the same type of deal. I'm going to take the limit as h goes to 0 of 1 over, so it's f of x plus h. So that looks like x plus h goes in there for x, minus f of x, which is what? 1 over x. That whole thing over h. Do you guys see where that setup came from? Okay. I'm taking x plus h and I'm plugging in here, so it's 1 over, it's limit of f of x plus h, which is what this is. This is f of x plus h. This is f of x over h. Now I do some algebra. I multiply this side by x plus h over x plus h to get a common denominator. And I multiply this by, no I don't. I multiply this by x over x, right? X over x. And I multiply this side by x plus h over x plus h. Okay? And now I get x minus the quantity. Don't forget, you have to put this in parentheses. X plus h over x times x plus h is now my common denominator on the top. X times x plus h. That whole thing over h. And I'm going to take the limit of that as h goes to 0. What simplifies on the top? Go ahead, Savannah. What's x minus x?
Nothing.
Nothing. What's minus h?
So it'd be plus h.
No, it'd be minus h because
No.
it, yeah?
Yeah, it would be minus h.
It's minus h because you're subtracting this whole thing. So you have a minus h on the top. On the bottom, you have an x times x plus h.
Wait, but that's in parentheses.
Right, so you have to distribute through the negative sign, right?
Hey, come on.
Oh.
Yeah. And then I'm going to take this is like h over 1, right? So I'm going to flip it and bring it up top. 1 over h. What could I do with h's now? Cancel this with this. And what I have is the limit as h goes to 0 of negative 1 times 1, which is negative 1, over x times x plus h. Now what do? Plug in 0, and that gives me x down here, so I get that's equal to negative, no more limits, now I'm taking the limit, 1 over x squared. And that's the equation of the derivative. That's equal to y prime, which is equal to 2y dx, or whatever. So, thinking about this, you may or may not know that this curve looks like, who knows what this curve looks like?
Sideways parabola.
Yeah, it's very good. Not a sideways parabola.
Is it just?
It's a, it's one of these things.
Oh, that's what I meant.
Oh.
It's a hyperbola that looks like this, and then looks like this. Okay, that's what that function looks like. So say I want to find f prime of 2. What's the slope going to be? Negative 1/4. So that's equal to negative 1/4 when I plug in here, right? And so if you think about it, this is about 1 when you get to 2. Does it appear that the slope of this line going kind of like that is negative 1/4?
Yeah.
Sure, okay. What kind of value would I expect to get at, for instance, x equals, how about f prime of negative 1? What do I get out? I get negative 1 divided by negative 1 squared, which would be, negative 1, right? Which means that at this point, when x is negative 1, about there, the slope of my curve is going to be, let's change colors.
Mr. Luder, that's not the right graph.
Yes, it is. Yes, it is. Believe me.
Plug it in my graph.
Well, you plugged it in wrong.
No?
Yeah, no, it's right. And I'm not graphing 1 over x squared, Henry. I'm graphing this, 1 over x, right?
Oh.
Yeah, the derivative, I know what 1 over x squared looks like too, right? That's the graph of the derivative. That looks like this, right?
Yeah.
Yes, okay? But this is the derivative equation. This is the original function. The derivative equation gives you the slope of the tangent line at any point. So isn't that cool? It's kind of cool. That's calculus. That's what you'll learn again. There'll probably just be 1 question, maybe 2 on this stuff on your final. But you'll spend like first couple weeks in calculus doing it. You can take it. Okay. Your homework is, I'm done.
This isn't for seniors, right?
What?